Here we have a 7-hour clock, and we're going to look at some of the properties multiplication for 7-hour clocks. So here's a table of multiplication for 7-hour clock. Now I've just written the table down. You can figure out the table. If you could figure out the 5 and the 6, you could figure out a 7. The identity is 1. It's the thing that doesn't change things. And we note that I've underlined those in blue, the numbers in that row and column. And we see that the column repeats this column, the row repeats this row, so that the row and column do repeat. So the identity is 1. We see that the table is closed because the numbers that we get down here are the same as the numbers we get here, and I'm not going to write that one out. The table is commutative. The order doesn't matter because every row is the same. The row for 3, for example, is the same as the column for 3. Every row is identical to the corresponding column. So order doesn't matter when you multiply two numbers on a 7-hour clock or on any other clock, it turns out. So that the operation is commutative, has the commutative property, the property of commutativity. The table has the inverse property because the inverse, the identity, which is 1, appears. I'm sorry, the table doesn't have the inverse property. We see that 1 does appear in every row, so we have a lot of pairs of inverses. 1 and 1, 2 and 4, 3 and 5, 4 and 6, 4 and 2, 5 and 3, and of course 6 and 6. We'll note that 2 and 4 are inverses, 4 and 2 are also inverses. If 2 and 4 are inverses, 4 and 2 have to be inverses, if the table's commutative especially. Okay? But it turns out, well, never mind. Okay. These are pairs of inverses, but the table doesn't have the inverse property because 0 has no inverse. So we can't say that the table actually has the 0 property. There's no 0 property associated with this table. There's another property called associativity, but we'll look at that in terms of more general operations. This table certainly does, and this operation certainly does have the associative property. Let me just write a little bit about the associative property here. Associative property states that A times B times C equals A times B times C for the operation, or we'll say is congruent to A times B times C mod 7 in this case. This means that if you multiply A and B and then multiply the result by C, it comes out the same as if you multiply B and C and then left multiply that by A. Do A times the product of B and C. And that is a property, of course, of all real numbers, and it's pretty easy to deduce that that has to be true of modular arithmetic also.